Hi class, today we are going to go over section 3.3, which is where we learn how to divide polynomials. At the end of divide, sorry. All right, so the first thing we're going to learn how to do is how to do long division with polynomials. All right, so the first bit of this is we need to know a very important theorem called the division algorithm. So that says that if P and D are polynomials, with d of x not equal to the zero polynomial. So that's what this big zero means. It means that the whole function is not just zero everywhere. Then there exists unique polynomials we'll call them Q and R, where the polynomial R is either 0 or a degree less than our original D. Oops, less than with an N. All right, and then it's such that we have this form here, such that P of x over D of x equals Q of x plus R of x over D of x. So the reason that we gave them these letters is because we have our polynomial P, our divisor D, and then Q is our quotient. Whoops, it's a U there, I promise. And then our remainder polynomial, which is of degree less than D. All right, and we can also write this as P of x equals D of x times Q of x plus R of x. So yes, so this is both of the forms that we are able to use when using the division algorithm. So then we can do an example on how to do long division. We'll start with our first example. So we're going to have 6x squared minus 26x plus 12 all over x minus 4. All right, we're going to set this up like when you originally learned how to do long division. We're going to put the divisor over here, x minus 4, and it's getting divided by 6x squared minus 26x plus 12. All right, so first, we're going to divide the leading term in the divisor by the first term in the quotient. So here we have this 6x squared, and we're going to divide that by x. So we have 6x squared divided by x equals 6x. All right, and then we're going to multiply the divisor by this value here. So 6x times x minus 4, this equals 6x squared minus 24x. All right, and then in our original problem up here, we have x minus 4, 6x squared minus 26x plus 12. We're going to take this 6x that we found and we're going to put it above our 6x squared. Oh, sorry, there's no squared. And then we're going to take the bit that we found here and we're going to write it underneath here. We're going to write 6x squared minus, 24x. And then we're going to subtract. We're going to subtract this whole thing. So then we will get a 0, and then we will get a minus 2x. All right. And then, oh, whoops, I accidentally wrote a 2. This should be a 12. All right. And then we're going to bring this 12 down. And now we repeat our steps. So this time we have minus 2x divided by x, which just equals minus 2. And then we have minus 2 times x minus 4, which gives us minus 2x plus 8. So if we take our original thing up here, and now we have oops, okay, there we go. I'm just going to write what we originally had and skip the step in between. And now we write this underneath again, just like before. We write this part underneath again. And we subtract it. And then we get a 4 here. So this 4, this is our remainder. So now we compile all the pieces that we have. Oh, whoops, I forgot to write up here a minus 2, because that is what we found here. All right. So then we write our answer out. So we have that 6x squared minus 26x plus 12 all over x minus 4. This equals 6x minus 2 plus 4 over x minus 4. Or, because we have that other version too, 6x squared minus 26x plus 12 equals x minus 4 times 6x minus 2 plus 4, where this is our D, this is our Q, and this is our R. All right, so that's how we do long division. So now we're going to do another example and do it all at once instead of broken up into these small steps. All right, so we have our new example. We want to divide 2x squared minus 5x minus 7 by x minus 2. So we write it out again, x minus 2 dividing 2x squared minus 5x minus 7. So first we start by dividing our first term with the first term in our divisor. So we have 2x squared over x equals 2x. So we write this 2x in the first bracket. So we have a 2x. And then we multiply 2x by x minus 2. So we have a 2x squared minus 4x. And we subtract this whole thing. So with that, we get a minus x. And then we bring down the minus 7. So then in this case, we have a minus x divided by x, which just equals minus 1. And now we do a similar thing where we multiply this minus 1 by our x minus 2. Then we get a minus x plus 2. And now we subtract this. So in this case, we get a 0, and then we get a minus 9. Because -7 minus our positive 2 is minus 9. All right, so therefore, our 2x squared minus 5x minus 7 divided by x minus 2 equals 2x minus 1 minus 9 over our x minus 2. Or, because we also have that other way to write it, 2x squared minus 5x minus 7 equals x minus 2, 2x plus 1. I'm so sorry, this should not be a plus 1. This needs to be a minus 1. I have that written wrong in my notes. So, yes, it was just there that it was written wrong. Okay, perfect. A 2x minus 1 minus 9, where this is our d of x, this is our q of x, this is our r of x, and this originally here is our p of x. And remember, r of x, it's still a polynomial even if it is just a constant like -9. That's totally fine to have. And it often happens in these division problems that your remainder is just a constant. All right, so now we're going to learn a different method for dividing polynomials called synthetic division. All right, so this is a quicker method for when our divisor So it's when our divisor is of this form, x minus c. And this is the really important part. You can only use synthetic division when your divisor is of this form. And we will abbreviate our polynomials by its coefficient when we are doing this, which will make sense once we start our first example. So if we look back at our example 1 that we did earlier, I'm going to rewrite it for you, so don't worry. So we have 6x squared minus 26x plus 12 all over x minus 4. All right, so here we have our minus 4, which means that our c equals 4. And then our coefficients over here, they are 6 minus 26 and 12. So then the way we set up our synthetic division problem is we write our initial c, which will be 4, and then we write our coefficients just as the numbers. So a 6, a minus 26, and a 12. And we're going to add the numbers that we add here, and we're going to multiply. So first, our first step will be, you just bring the first number straight down. You have a 6. And then we're going to do 6 times 4. We're going to multiply. And 6 times 4 is 24. And then we're going to add down. So negative 26 plus 24 gives us a negative 2. And then we're going to multiply. And negative 2 times 4 is negative 8. And then we're going to add down, and we get a 4. And now here, this will give us our quotient coefficients. And this will give us our remainder. And remember, we have our c here, and these are our coefs, or coefficients. Okay, so then when we rewrite it, we end up with our q of x equaling 6x minus 2, and our r of x equaling 4, which matches our answers from the example 1 with long division. All right, so then we can do another example and run through it again. So we're going to divide 2x cubed minus 7x squared plus 5 by x minus 3. So again, we have our x minus a number in the same form, so we can use synthetic division. So we will write our 3. We need to write our coefficients out. So we have a 2, a minus 7, and then notice that there is no just x term. So we put a 0 there for 0x, and then a 5. So we have our divisor. And these are our coefficients again. We bring our 2 straight down, and we have a 2. 2 times 3 is 6, so we multiply. And then we're going to negative 7 plus 6 is negative 1. Negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. And then 3 times negative 3 is negative 9. 5 plus negative 9, that equals negative 4. So here again we have our coefs. And here we have our remainder. So when we write it out, our Q equals 2x squared minus x minus 3. And the way to look at this is you always start with this rightmost one. This is our constant. And then as you go forward, you add an x term. So an x for our negative 1, and then an x squared for our 2. And then our r of x equals minus 4. So when we write out our answer, we have 2x cubed minus 7x squared plus 5 all over x minus 3 equals 2x squared minus x minus 3 plus negative 4 over x minus 3. Or, because we always have the 2 ways to write it, 2x cubed minus 7x squared plus 5 equals x minus 3 times 2x squared minus x minus 3, all minus 4. All right, so moving on from here, we're going to go over some important theorems that help us with understanding how dividing polynomials works and why it's important. So our big theorems are the remainder and the factor theorems. So the remainder theorem is as follows. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. All right. So the big idea with this is that if we have p of x equals x minus c times our q of x plus r, some remainder. And we can remember from earlier that our remainder is always a degree less than our divisor. And since our divisor is just an x, this means that our remainder has to be a constant. So then we're going to let our x equal c, and then we're going to plug it in. So then P of c equals a c minus c times our q of c plus r. But this here, this equals 0. So that means we just have that P of c equals r, which is what we wanted. So we proved this theorem up here. So we're done. So this will be helpful when you are checking your division after you're done. You can check that your remainder is what you thought it should be. And that's a really nice way to check what you're doing. All right. So then for our next theorem, it's the factor theorem. So it states that C is a 0 of P, of our polynomial P, if and only if x minus C is a factor of P. All right, and the idea on this one is that if x minus C is a factor, then P of x equals x minus C times some other polynomial q. That's what this means. Well, this means that our r equals 0. So that's what we wanted. So that means that there's no remainder. And then the other direction, if P of C equals 0, then by the remainder theorem, P of x equals x minus C times Q of x plus 0, which this just, actually don't want that there, mark it down. And this just equals x minus C times Q of x. Well, this means that x minus C is a factor. So we have that if it's a factor, we have a remainder of 0. And then if there's a remainder of 0, then it's a factor. So therefore, we approved this whole theorem. And this is another just helpful tool for if you're going through and you're dividing something and you get a remainder of 0, you know that that's going to be one of your factors. And later, as we move on and we are graphing more complicated functions, this will be really helpful when finding your x-intercepts. All right, and now we're going to learn how to apply the factoring theorem. All right, so now we're going to apply this theorem that we just learned about. And we're going to illustrate how to do this with an example. So if we let our polynomial be x cubed minus 7x plus 6, and we want to show that p of 1 equals 1, and use this fact, factor p of x completely. All right, so first we need to show that p of 1 equals 1 cubed minus 7 times 1 plus 6. I have here that it should be that p of 1 equals 0. Sorry. All right, so this will then become 1 minus 7 plus 6, which equals 0. So by our theorem, x minus 1 is a factor. All right, so now we're going to divide it out, and I'm going to do it both ways. First with long division and then with synthetic, so you guys get another example of how to do both. So first we have our x minus 1, x squared plus, oops, that was wrong, x cubed, and then we're going to remember our minus 0x squared, because in our initial problem there's no x squared term, minus 7x plus 6. All right, so x cubed divided by x is x squared. And then we're going to multiply that through, and we get an x cubed minus x squared. And then we're going to subtract, and we get a positive x squared, and bring down the minus 7x. And now x squared divided by x just equals x. So then we add an x. Then we multiply it through, so we get an x squared minus x. And we subtract this, and we get a minus 6x. And then we bring this down. And minus 6x divided by x just gives us minus 6. And we multiply it through. And then when we subtract, we just get a 0. So this means that our q of x equals x squared plus x minus 6, and our remainder is just 0, which is what we knew it should be, because when we do our polynomial at 1, we get 0. So it made sense that it was a factor. All right, and now we're going to check it with synthetic division. So since our divisor is of the form x minus 1, that means this part is what we add at the beginning. So it'll be 1 with just the coefficients listed, which is, actually, I'm just going to rewrite the problem so that you guys can see and don't have to scroll back up. So we are dividing x cubed minus 7x plus 6 by x minus 1. So this is of the form that we want. So we'll have our 1, and then our 1, our 0, our minus 7, and our plus 6. Or I don't need a plus there. Just a 6 is fine. All right. And we bring down our 1, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and we add. So here, this is our Q, and this is our R. So this also matches what we want. And then when we write this out again, our Q of x equals x squared plus x minus 6. And this matches what we have up here. So now we're doubly sure that what we have, and then we can factor our Q of x even more to make it, and it's pretty clear that Q of x can be factored into x minus 2 and x plus 3. So that means that P of x equals x minus 1 times our initial x squared plus x minus 6. And then with our factored form, and there's a secret like plus 0 added here from our remainder. So now we have a fully factored polynomial. Which is really helpful in finding the zeros of graphs when we're graphing it and finding different roots. It's often nice when we can factor our polynomials into a really clean form. So this is several techniques on how to divide polynomials and some good methods with it. All right, see you guys next lecture. Bye.